Hello, welcome to this presentation called Teaching Kids to Code from Consumers to Creators. In this presentation, we're going to be looking at some of the different ways which we can help to teach children of elementary age to become coders, computer coders. Throughout this presentation, I will be mentioning many resources, and you can find all of those by visiting this URL on the bottom, teachtocode.weebly.com. I will leave that URL on the top of the screen for the next couple of slides, just to give you time to write it down. Before we start, let's take a look at some success stories of some young developers. Let's start with 4Snaps, an app which was downloaded over 600,000 times. He was 16 when he created it, and he now works for Facebook. Michael came up with the idea whilst watching his sister play a game with her friends in the kitchen. They would send each other pictures, then try to guess the word, and he thought to himself, this should be an app. Then there's Sumley. Whilst revising for his exams, this 15-year-old boy was tired of having to read through pages and pages of text. He wanted to get a summary of the important stuff quicker. Nick was the creator of the Sumley app, downloaded just under 1 million times and then sold in 2013 to Yahoo for $30 million. And last but not least, we have Bustin' Jeever. Thomas Suarez was 12 years old at the time when he created this app. To quote, he said, "I created it because a lot of people at my school disliked Justin Bieber. I can't think why." Let's have a listen to Thomas speaking at a TED Talk.
I've always had a fascination for computers and technology, and I made a few apps for the iPhone, iPod Touch, and iPad. I'd like to share a couple with you today. My first app was a unique fortune teller called Earth Fortune that would display different colors of Earth depending on what your fortune was. And my favorite and most successful app is Bustin' Jeeber, which is a Justin Bieber whack-a-mole. I created it because a lot of people at school disliked Justin Bieber a little bit, so I decided to make the app. So I went to work programming it, and I released it just before the holidays in 2010. A lot of people ask me, how did I make these? A lot of times it's because the person who asked the question wants to make an app also. A lot of kids these days like to play games, but now they want to make them. And it's difficult because not many kids know where to go to find out how to make a program. I mean, for soccer, you could go to a soccer team. For violin, you could get lessons for a violin. But what if you want to make an app? And the kids' parents might have done some of these things when they were young, but not many parents have written apps. Where do you go to find out how to make an app?
I'm going to stop Thomas there. And I must mention that our aim is not purely vocational. It's not just to create the next future app developers. We're not looking at always creating people who are going to make millions of dollars. We can gain just as much satisfaction from kids who use Scratch, for example, to create greetings cards for their friends or family. Let's take a look at 3 now. As you have seen, our main focus does not have to be the creation of future app developers. We don't have to focus on producing kids who are excellent at coding, because coding can help with many other areas and help develop other skills, such as being creative and expressive. Perseverance, it takes a lot of perseverance for kids to go through coding from beginning to end. Coding should be broken down into different chunks so they learn about organisational skills. There's a lot of bug fixing and problem solving. Code always has to be tested and evaluated. They can develop collaboration skills, working with others. Also, there's many cross-curricular skills, such as storytelling perhaps with English, or physics using gravity in a game, and there's lots of maths involved as well. So, this is how I'm going to lay out this presentation. What are the objectives? First, we're going to talk about what has been the stimulus for this drive now to teach kids to code. Then I'm going to talk about what people are doing about it right now, what exists to help us. And I'm going to offer some suggestions about what we can do. To do that, I'm going to share with you lots of tools that you can use with the kids. For example, visual programming tools, games development. I'm going to show you how we can link the virtual world with the physical world. And of course, all of this doesn't really help unless I give you some support and show you how you can put these ideas into practice and through support and lesson plans. Also, I've created my own kind of framework, which I believe is a logical process to take kids through when teaching them how to code. Again, all of these resources you can find on the website teachtocode.weebly.com. What has been the stimulus for this presentation? We've possibly all heard the term digital natives. Children of today are digital natives. They find the use of technology intuitive, and they can learn how to interact with technologies that they've never seen before in a much shorter space of time than adults can. But what is it that actually children are doing with these technologies? Well, they're very good at gaming, excellent with social networking, texting, browsing the internet, and chatting. All of this together means they're excellent consumers of technology. But our aim now should be to move away from the consumption and to start promoting the creation of new technologies. The former Secretary of State for Education in Britain made a report where he addressed the need to provide more coding opportunities for children in schools and education. And in his report, he stated,
"It is estimated that over the next 10 years, there will be 1.4 million jobs in computer sciences and only around 400,000 graduates qualified to do them."
Okay, so this is one stimulus, the disparity between the number of jobs and the graduates qualified to do these jobs. This is the UK. Let's take a look at some infographics from the US. It stated that by 2020, there will be 1 million more jobs than students qualified to do them. So 1.4 million computing jobs and only 400,000 computer science students by 2020. Let's look at the job-student gap in computer science. So the 60% of the jobs will be computing related, whereas computer science students at the moment will only reach 2%. So why are the numbers so bad? The reason? The majority of schools currently don't even offer computer programming classes, or they don't offer enough. So what are people doing about it right now? What kind of initiatives exist? We've heard from Michael Gove, the Secretary for Education. He's promoted the inclusion of more coding in the curriculum quite heavily, actually, in Britain. So that's the national curriculum for the UK. Whilst watching a football game the other day at half-time, there was an advert on for Barclays where they promoted computer coding classes within the branches. So I had a look on the internet, and it said that if you wanted to send your kids to a branch, you could book an appointment to learn some computer coding, which I found fascinating. Every year there is for the last 2 years at least, there is an initiative called the Hour of Code. This is where during 1 week, the idea is to get as many students as possible to try at least 1 hour of code. And the majority of the resources I'm sharing with you today actually come from the Hour of Code website, which is very good. A lot of you maybe have seen Bite Size, BBC Bite Size. In the past, there was always good resources on here for science, English, maths. Now there's a huge section on computer coding. Made with Code is also a website created by Google to help kids learn coding. I know that in my school, I've been asked to look into including more coding in the Design MYP and in the Design MYP curriculum for IB. And in my previous school, I was asked to create a curriculum for primary school students to include more computer coding as well. What about your school? Can you tell me what kind of initiatives have started or do you do in your school? Simon Peyton-Jones, who was an advisor on the British National Curriculum Inclusion of Coding and also works as a researcher for Microsoft, had a very interesting thing to say. He highlighted that this is very much not vocationally driven, which is kind of the point I was getting at before. But let's see if Simon Peyton-Jones can say it better than me.
We teach every child science and English, even though they're not going to become English dons or scientists. But we want them to know some science, because we want them to know something about the world that surrounds them. In the same way, we want them to know some of the elementary principles of computer science.
So the point he's getting at is, again, like I said before, we don't have to teach them coding so they become coders, but the same with science. It's just good to know how the world around you works. And the world around our children today is full of technology. So what can we do about it? Let's move on to the next stage of the presentation. As I mentioned, I've come up with a framework which I believe you can use to follow a logical process of teaching kids to code. On the right-hand side, you'll see the younger kids section. And on the left-hand side is slightly older kids. So I would say the left-hand side was probably from grade 3 up to grade 6, and the right-hand side from, say, kinder to grade 2. And a good place to start with anybody, it doesn't really matter how old they are, is to talk about giving instructions, because that's basically what coding is. Coding is giving a set of instructions to a computer to tell it what to do. But with the younger kids, we don't even have to relate it to the word coding or computing even. We can start to get them to understand and give instructions. And then we can slowly start to introduce some important vocabulary which is linked to coding, such as repeat and functions. So let's look at an example. You could get the child up to the front of the classroom and you could ask him to give instructions of how to make a square. So get the kid to stand in front of the classroom, get another kid to shout out the instructions, and hopefully you will get something like this. Forward 1, turn right. Forward 1, turn right. Forward 1, turn right. Forward 1, turn right. So then you've congratulated the student and you say, well, how could we make that code neater and tidier, smaller, by using the word repeat? What can we do? And hopefully they will come up with repeat 4 times. Forward 1, turn right. So already you can start to see we're getting into some coding vocabulary. And then again, you could even take it a step further and say, well, how about we save this instruction and just call it square? So, which is actually like a computer coding function. So with the basics of giving instructions, you can then move them onto control devices, where they get robots, for example, and they have to give them instructions to go around obstacle courses, etc. So a couple that spring to mind, the Bbot, I've used those before with young students, and even though they get confused with left and right, they're good devices to use for helping them make predictions, like what will happen if I press this and press this. And although I haven't used them, Bo and Yana, I've heard good things about them, and perhaps you could check them out yourself and let me know. So before I start to talk about visual programming tools, let me just quickly explain what that means. So in computing, a visual programming tool allows the user to create programs by manipulating graphical elements, visual elements. So they snap bits of code together, just like Lego, rather than by specifying them textually, which is writing chunks of code. So if you look at this example, you can see here, this is writing chunks of code. It's very dry. It's probably find it a little bit boring at the start. So something which is much more engaging is visual programming tools, like Scratch here, where you get bits of chunks, visual elements of code which you have to link together. Let's take a look at a couple of examples now, which I have also included on the website Teach to Code. So let's look at a couple of visual programming tools for the younger children from kinder to grade 2. Too Simple has a good selection of resources. One of them is called To Go, which is very simple. It's like the old style logo programming language where you give instructions to get objects around a screen, tell it how many steps forward, to turn right, turn left, and it has different levels of difficulty. That was for the computer. You can use that on your browser. There's another one called Learn Coding with Daisy, which you can use on the iPad. Let's take a quick look at that now. Let's have a look at a video. So again, it's visual programming. You can see you've got to drag visual parts, visual chunks together and put them in the right order. So let's take a look what's happening. The idea is to move and jump and get the star. Amazing coder. Make Daisy spin 5 times. So, spin, 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 spin. Now you can introduce the repeat function. So, same thing, this time, repeat 5 times the spin. You've completed the challenge. You are an amazing coder. Also, I'm going to show you now Scratch Junior. A lot of you probably heard of Scratch, but maybe not Scratch Junior, which is, I believe, is a relatively new app. Currently, it's only available on the iPad. But what I've been impressed with most with this are the accompanying resources. So there are a number of projects on there, and each project has around 5 lessons. And each lesson takes about an hour to complete. And it comes with full worksheets and full step-by-step guides for the teacher and for the student. And it's not only the way it's so detailed, but it also is sections so that you can aim the lesson to various ages. So you can aim it at kinder. It shows you how you can aim it at grade 1 and 2, or aim it at all other ages. So here you can see an example of a module, making a Scratch Junior collage. It's got 4 lessons. And each lesson plan itself has the objectives. It has step-by-step instructions how to do it and how to aim it at different age levels. So the accompanying resources are very good. Let's take a look at this right now. So let's take a look at Scratch Junior. Let's see what kind of changes they've made since the first one. Okay, let's go to Home and let's make a new project. Straight away you can see there's some big differences. It seems to be more younger child friendly. Okay, let's start by maybe choosing a background. I'm going to choose the street. And then I'm going to change the cat. And I'm going to make a new character. So what do I want to cross the road? Obviously, I want a chicken. So let's put the chicken at the start of the road. Now, the yellow objects will give me the green flag. So when the green flag is clicked, I want to move. But do I want to move one step? No. On the top, I have a grid. I can turn that on and I can see I want the chicken to move 20 steps. So, change 20. And then I'm going to click on the green. Let's see what happens. Very good. So there's been some big differences, big changes with Scratch Junior. I think that's well worth investigating. Let's move over to the older kids now in the primary school, from grade 3 up to 6. So not really that old. But what I would usually start with is actually explaining what coding is. I would explicitly say that we were beginning to learn how to code. So in the past, I've used a video explaining the basics of what coding actually is. So let's take a look at that now. I made a video and I put it in the app EduCanon. So the video stops at stages to ask questions to make the video more engaging. Let's check that out.
Code is everywhere. Code is a software language for computers. It is a set of instructions that tells a computer what to do. Code by satellites so they can relay our television programs into our homes. Code keeps airplanes up in the sky and gets them from one side of the world to the other. Code is used in modern cars. It tells you when you have run out of petrol. It controls the satellite navigation system and will show you how many miles you have travelled. Code is used to turn traffic lights from red to green. Many systems that you might not expect use code, such as microwave ovens, toasters, fridges, washing machines, and TVs. Code really is everywhere. But what is code? Developers write code using a software language to create a software program or a website. A program can be an operating system or an app. Just as there are many different languages spoken in the world, there are also many different software languages. These are often suited to different types of program, and developers will specialize in certain ones. For example, Scratch, Python, and Odoo are good for writing games. HTML, PHP, and CSS are often used for creating websites. These languages are used by developers to create mobile apps. Let's have a closer look at an app. Did you know that it took a team of 12 developers over 8 months to write the first version of Angry Birds? To create an app, or a website, or a piece of software, a team of developers will work together with many others, such as testers who make sure there are no bugs in the software, and designers who provide the exciting graphics. If you can write code, you could be part of the development team that creates the next Angry Birds, or you could work for Facebook. You could work for pretty much any company in the world, writing their software or making them cool websites. So, what are you waiting for? Code is everywhere and there are many opportunities to get involved. Welcome to the world of coding.
Regardless of age, you can still talk about giving instructions as the next step. You could even do the same exercise about giving instructions to make a square. Now, I'm going to show you some visual programming tools, and we're also going to introduce the if function and the variables as well. But before we do, let's have some audience participation. The most obvious visual programming tool out there is Scratch. So let's have a bit of audience participation in this game of Scratch. Game created in Scratch. Now the good thing about this is we don't control the bat with the keyboard, you control it with your voice. So I would like you to work together to see if you can eat at least 10 bugs. Let's see how this works. Come on, come on, come on. Eat! There you go. So I think 10 was a bit optimistic. Let's go back to the presentation. Okay, so Scratch is the obvious one. And on the website that I provided, teachtocode.weebly.com, we'll now look at some others. So here's the website. If you can see on the menu on the right hand side, we've got some visual programming tools. Let's take a brief look at some of the examples that are out there. Most of these, like I said, come from the Hour of Code resources. We have Angry Birds, Flappy Bird, what all the kids love. We have Scratch, we've got some lesson plans there. So wherever possible, I put links to lesson plans. So like I said, there's no point in giving you tools unless I give you ways to use them as well. Blockly is another good one to use. Tinker, this is a very comprehensive one. You have to pay for it, but you get a whole host of lesson resources and kids can follow it at their own pace in kind of like a game adventure mode. So it's very recommended, Tinker. But I'm going to show you Angry Birds now. And with Angry Birds, we're going to look at the first level, just to see how it works. Let's skip the video. So, puzzle 1 of 20. Can you help me catch the naughty pig? Stack a couple of move forward blocks together and press run to help me get there. So I am the Angry Bird and I have to get the green pig. So the idea is to drag blocks of code in the right order and then hit run. So maybe you can help me out here. What do you think will happen if I press run now? Will it work? Of course not, because we need 2 blocks of move code. 1, 2, and then it should eat the pig. And not only can you work on the visual code, you can also show them the text code as well, so they get an idea of what it is that they've been doing. So I know that I need to move the Angry Bird 1, 2, turn, 1, 2, turn, 1, 2. So I can repeat something 3 times. I've already got my repeat block, so I need to move forward. 1, 2, turn left or right? Let's try right. Let's give it a go. Excellent. If I show the code, I can see, it's starting to get a bit more complicated now. If statements. So now we're getting more advanced. Use the new if block to let me decide when to turn. Okay, so now we have to introduce the if statement. So I can say I have the zombie, and I need to get the zombie to the nice flower without walking into the bad flower. So I can say I have a repeat until I get to the flower. I need to do something. So I'm going to move forward. If the path turns to the left, what do? So I should turn left and move forward. Let's try it. Brains. Excellent. How do you each stage in any of the examples that I've showed you, you can introduce bug fixing. So you can break bits of code and ask them to fix it. You could introduce the concept of making predictions, give them different scenarios and ask them, what do you think will happen in this one or in this one, or if this happens? And it's also quite easy to differentiate the learning. So you can set a basic task, but then there's always possibilities for the more advanced learners to take it that one step further. Talking of advanced learners, I'm going to have some more audience participation now. So I'm going to give you a challenge. We have a car that goes around a grey circle and we control it with voice. But I want you to take it to a new level. Let's have a look at that. So Sound Racer on Scratch. When I click go, the car should spin round. And I want it to go around the grey circle. To do that, I have to shout when it's pointing in the right direction. So let's try it. Go! Go! And I could go on and on and on. But I'm not going to. Because what I want you to now do is, I want you to change that so that if the car touches the grey circle, it stops and it goes back to the start. And you have to keep going until you can get around the circle without touching it. So that's your challenge. So this is what it looks like inside the game. Here we have the car, and we can see where it starts. We have coordinates X and Y. So we can determine where to put the car by the coordinates. I'm going to take out this code now, and I'm going to ask you to try and fix it. So at the moment, the car could touch the grey, nothing happens. We've seen that. So what do I have to change in here to make it so that when it touches the grey, it goes back to the start? So let's have a look in events. Doesn't seem to be anything there. How about sensing? Sensing. Aha, sensing. So, touching something. I want an if. If touches something. So let's have a look. If touches. Let's go back to sensing. If touching this colour green. No, not the green. If touching the grey colour, I want you to go to some coordinates. Let's see which code. Go to which code? I want to go to 162.121. Remember, here's the coordinates. So 162. Oh, I've forgotten. 121. Let's give that a try now. So allow the microphone. Go! Go! I'm going to hit the grid. Go! And I go back to the start. Excellent. Now we get into the really fun stuff for the kids. Games development. I can tell you from experience that when the kids reach this stage, this level, they are so engrossed and so engaged. In a previous school, almost every lunchtime, I had a load of kids coming and saying, "Can we use this app, this iPad app, to create games?" This particular app was called GamePress. But there's a couple of apps I'd like to show you. One's called Hopscotch, which is more basic, but still very engaging, and then GamePress. So these are for the iPad. I know from experience that the kids love them. But there is also other tools out there which you can use to create games, which I've put on the website, such as Game Salad and Construct 2. So I'm going to connect to the iPad now, and let's take a look at these two apps.
So let's take a look at the Hopscotch app. Fantastic for introducing kids the language of code. So I'm going to start a new project here and show you how easy it is. I'm going to select the gorilla as my main character here and press start. Now you can see there that it says when I press play. Well, I'm going to teach code my gorilla to move left and right when I tilt my iPad. So the first thing I need to do is press the drop-down menu, and I'm going to program my gorilla when I tilt the iPad right, I want him to move right. So I'm going to go over to my left, see where it says motion, top left-hand corner, and I'm going to drag the move coding block over underneath that command. I'm going to change it to, let's say, 300, press enter, and now when I press play, when I tilt my iPad to the right, it will move a certain distance. Let's test that out. Press play, tilt my iPad, you can't see it, but he's actually moved. That's fantastic. Now, this is a real magic moment for kids when they learn for the first time that I can actually program a computer or a device or anything to do something. It really is a magic moment.
So ideally, we want our students to progress from visual programming to text-based programming. This is not to say that in the future all coding won't be visually based, but that's just the way it is right now. I've given some resources on my webpage, from very basic to more challenging, where you can get your kids to practice text-based coding. The important thing is, if you're giving kids this kind of work to do, try and keep it relevant and practical. They can follow all the tutorials in the world, or the games-based learning activities, but where does it lead? They probably will learn it, it'll be in one ear and out the other. So when you give them a project, try and give it something that they can apply, something practical, something where they can be creative and produce something. A very good way to give students a practical use of text-based coding is to use HTML, so they can create their own websites. The reason being is that they can instantly see their results. So they program a little bit of HTML and straight away they start to see changes on their websites. And everybody uses websites. And then the added advantage is, if you have kids that are more advanced, you can move to other languages on the website, such as CSS or JavaScript, for added functionality. Now, the ultimate aim for me is, well, go back a bit. One of the best ways to make coding relevant and project-based is to link the virtual world with the physical world through robotics and electronics. I have to admit, I'm a novice with Raspberry Pi, but this week I've been investigating its uses, and there are a whole host of resources out there for potential school and home projects, and I've been very impressed. So what is a Raspberry Pi? Raspberry Pi is a credit card sized circuit board, which is basically the same as a computer, like the computer I'm using now, but much more basic. And the kids themselves, or anybody, not just kids, adults, have to give the circuit board a set of instructions to tell it what to do. So many things you can do with a Raspberry Pi. And the good thing is, there's a lot of resources out there giving projects step by step of how to do it. On the Raspberry Pi website itself, there is a section called Make Resources. And one of the projects I followed this week was called
So in this video I'm going to very quickly show you the Screaming Jelly Baby. So I've connected up a speaker, jumper cables to GPIO pins, as you can see there, and I've connected those to paper clips and an unfortunate jelly baby, as you can see. Okay, it's quite a short program in Python, and it plays a file called Scream MP3. If I squeeze the jelly baby,
Screaming Jelly Babies. Obviously, you can't see any practical use for that at all, but it is a bit of fun. And believe me, on the website, you can see a whole host of resources for really practical projects for the kids. So, in conclusion, this presentation was called Teaching Kids to Code, and I've showed you a number of ways which you can teach kids to code. You can find all the resources on the website, teachtocode.weebly.com. But the main aim is to take the kids from consumers, so users of technology, users of these apps, to creators. So start them on the path, give them the inspiration, the motivation to code, and then hopefully they will take it from there themselves, and then they will start to create, and you'll be amazed at some of the things they really can produce. Thank you.